Kavita, Assistant Professor, Department of ECE, Ratnam Technical Campus. Today I am going to deliver a lecture on PN junction diode. So first of all, what is a diode? Have you ever wondered how the mobile charger converts AC into DC or LEDs emit lights? So the answer lies in the simplest but the most important semiconductor device called diode. Upon completion of studying this topic, a student can able to understand what is a diode, how the PN junction diode is formed, and the working principle of PN junction diode under different biasing condition called forward bias and reverse bias. So what is a diode? Di means 2, ode means electrode. So diode is a device which has 2 electrodes called anode and cathode. So a diode is a unidirectional electronic device. So what is mean by unidirectional device? A diode allows the flow of current from one terminal to another terminal, that is in the forward direction from anode to cathode, and blocks the flow of current in the reverse direction, that is from cathode to anode. Generally, silicon is used to make a diode. So not only silicon, germanium and gallium arsenide are also used to make the diode. So what are the silicons, germaniums and gallium arsenide? These are all semiconductor materials belongs to group 14, which has valence electrons 3 in the valence band. So what is semiconductor? Why the semiconductor materials are most widely used to make a diode? Why not the conductors and insulators? Usually conductor has a high conductivity and insulator has very low conductivity, that is a zero conductivity. But the semiconductor, the conductivity of the semiconductor lies between the conductor and insulator. So as the conductivity lies between the conductor and insulator, one can able to control the conductivity of silicon or germanium or gallium arsenide based on our application. So that the semiconductor materials are widely used to make the diode, not only diode, all these semiconductor devices rather than insulators and conductors. So the construction of a diode. So before entering into the construction of a diode, we need to know what is doping and how the p-type materials and n-type materials are formed. So doping is nothing but adding impurities with the semiconductor material. So how the p-type materials are formed? Usually semiconductor has 2 different forms, intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are semiconductor which has equal number of electrons and holes at room temperature. So intrinsic semiconductors are not usually used to make the diode because the conductivity of the intrinsic semiconductor is very low at room temperature. So that the extrinsic semiconductors are manufactured. So extrinsic semiconductors are manufactured 2 different ways, by adding trivalent impurities with the intrinsic semiconductor and adding pentavalent impurities with the intrinsic semiconductor. So how the p-type semiconductor material is formed? It is formed by adding trivalent impurities like boron, aluminum, gallium with the intrinsic semiconductor. So for example, take boron as a impurity atom which has 3 valence electron in its valence band with the intrinsic semiconductor, that is silicon, which has 4 valence electrons in the outermost layer, that is valence band. So when we add boron with the silicon, a boron has 1 hole in its valence band. So this is nothing but positive charge and it can able to move around the material. Now how n-type materials are formed? N-type semiconductor material is formed by adding pentavalent impurities like antimony, phosphorus and arsenic with the semiconductor material silicon. So for example, take the phosphorus as an impurity which has 5 valence electrons in its valence band. With the semiconductor material silicon, it leaves 1 extra electron. This electron is called as free electron and it can able to move around the material and constitute current. So that n-type material has majority carriers of electrons and p-type materials has majority carriers of holes. So how the PN junction diode is formed? By adding or by joining p-type material with n-type material, a diode is formed. While joining p-type and n-type material, a junction is created between them. So that junction is called as PN junction. So that diode is named as PN junction diode. The working principle of PN junction diode under no biased condition. So when we join p-type and n-type material, due to the diffusion difference across the material, the majority carriers like holes and electrons move, that is diffuse the junction and forms ions. So these ions are collected across the junction and the layer is called as depletion layer, and the voltage difference across the depletion layer is named as barrier potential. This barrier potential is 0.6 voltage for silicon and 0.2 voltage for germanium. So now the working principle of PN junction diode in reverse bias condition. So what is called biasing? So biasing is nothing but applying external battery or external potential to the diode. So what is called reverse bias? So when we connect positive polarity of the battery with the n-type material and negative polarity of the battery with the p-type material, it is named as a reverse bias. So when we increase the reverse bias across the diode, the depletion layer width increases. So how the depletion layer width increases? So from the statement of Coulomb's law, like carriers repel each other and unlike carriers attracts each other. So from this statement or from this principle, the majority carriers, that is holes in the n-type material, attracts towards the positive polarity of the battery, and holes in p-type material attracts towards the negative polarity of the battery, so that the width of the depletion layer increases and there is no flow of current across the diode. So when we increase the negative potential beyond certain level, the Zener breakdown occur. At that point, the current increases suddenly through the diode. Next, forward biased condition. So what is mean by forward bias? Forward bias means connecting n-type material with the positive polarity of the battery and p-type material with the negative polarity of the battery. So from the statement of Coulomb's law, here the electrons and holes are attracted towards the positive and the negative polarity of the battery. It reduces the width of the depletion layer. When we increase the forward bias beyond 0.6 voltage, width of the depletion layer becomes 0 and current start flowing through the diode. So when we increase the biasing voltage, that is forward bias voltage, the current increases proportional to the forward bias voltage. So this is the characteristics of PN junction diode. In reverse bias condition, there is no current, only minimum amount of current flows through the diode because of minority carriers, and during the forward biased condition, the current increases proportional to the applied forward bias condition. So diode is used in different applications like converting AC into DC and some wave shaping circuits like clippers, clampers and multivibrators.